We're now close to the conclusion of the International Space Station's Expedition 43, which has been a very busy time for science for the 6 station crew members. That leads directly into Expedition 44, which will conclude or continue the 1-year mission and a lot of other research. Recently, my colleague Pat Ryan had spoke with Jorge Sotomayor, the lead increment scientist for both expeditions 43 and 44, to get an update, starting with the crew's work on a flame experiment known as Flex 2.
Basically, Flex 2 studies the combustion of tiny little droplets of fuel in microgravity and study the generation of soot during those tests. And Flex 2 studied different mixes of fuel and also studied, in addition to just one droplet of fuel, it also studied multiple fuel droplets, 2 specifically. So it wanted to study the interaction of the flame between the 2 droplets as they ignite. And actually, we have a new experiment coming up, Flex 2J, in collaboration with Japan. And in that experiment, we're actually going to test multiple droplets of fuel igniting at the same time and study the interaction of the flame as it occurs.
And it's important to know how flames burn in space because it's different than it is on Earth, right?
It is, yes. Yeah, we have a spherical droplet of fuel, so the combustion properties, and the fluid dynamics are different than what occurs in microgravity, than what occurs here on Earth. So with this information, we can design advanced systems for combustion systems for spacecraft, as well as study and design cleaner burning techniques for the ground.
Interesting. Now, there's also science on board the station that happens outside the pressurized modules. In fact, the robotic refueling mission had operations recently. Tell us about what that is.
Yes, yeah, the robotic refueling mission phase 2, or RRM as we call it, that mission studies how to repair satellites currently on orbit, but that were not designed to be repaired or refueled. So what RRM Phase 2 consisted of was the crew set up task boards and tools in the GEM airlock. Then the SSRMS, the robotic arm, came over and picked those tools up and installed them on the RM facility external to the station.
Right.
And the next phase is for the robotic arm to test those tools, simulating that it's doing a repair on a failed satellite. So the advantage of this is that we can extend the lives of the satellites on orbit that were not initially planned for replacement for long duration, and that will save cost to the companies on the ground, as they don't have to relaunch the satellites.
Yeah, clearly have some value. Another thing that got a lot of attention during Expedition 43 was the first espresso machine on board the station.
Yes.
That's not just for fun, right? Tell me about that demonstration.
Yes, yeah, that was a very interesting demonstration. It's an investigation from the Italian Space Agency, and basically it wanted to bring to the station the comforts of home from the ground, and actually, coincidentally, an Italian astronaut, Samantha Cristoforetti, installed the ISS espresso machine and tested it. It was all very successful, and so now what the intent is to, it not only helps in terms of bringing other options for food consumption to the astronauts, but also the psychological effect of bring it closer to home. Yeah.
I think this other thing was sort of a psychological thing too. They were using cups that allowed them to actually drink more like they would on Earth, as opposed to a straw in a bag.
Yes, capillary beverage. Yeah, that's that investigation studies how to use fluid dynamics on the design of a cup, so that the liquid doesn't spill. It's still an open cup, but the liquid doesn't spill. Again, using all the physics and fluid dynamics that go with it. Now, interestingly enough, this technology from Capillary Beverage is not only being used to design these cups, but also it will be used to design advanced fluid systems for spacecraft. So it seems very simple, but the physics involved are very complex and have a multiple application.
And a way to control the movement of liquids where there's no gravity, like pulling fluids to the bottom of a fuel tank, for example.
Right. Yes, that's a problem that we're working on.
The Expedition 43 crew's working on a couple of big experiments in the one-year mission coming up. Tell me about this fluid shifts experiment and what Scott Kelly's going to be doing inside a Russian piece of hardware.
Yes, that's a very interesting experiment. And fluid shifts, basically what the scientists want to study is the effect of long-term exposure to microgravity, and because the fluids shift from the lower part of the body to the upper part of the body, and that creates increased pressure in the brain, which at the same time then it increases the pressure on the eye, on the back of the eye, and that changes the vision of the astronauts. So the objective is to study how that happens and possibly identify countermeasures for that with that situation by testing the ocular structure and measuring the ocular structure and intracranial pressure, both outside of the Chibis suit as well as inside the Chibis suit. What the Chibis suit does, it's a lower body negative pressure, so it will simulate or avoid having those fluids shifting from the lower body to the upper portion of the body.
It kind of draws fluids back down into the legs, right?
Correct. So we want to take the measurements with and without the Chibis suit and see if it makes a difference.
Is there a thought that might be a way to fight the fluid shift? That we can do it with crew members throughout the mission, perhaps?
Correct, and potentially avoid temporary or permanent changes to the eye structure.
Scott Kelly and Mikhail Kornienko have also been working on a thing called fine motor skills. That's part of their one-year plan too. What do they do for that?
Yeah, that one, actually, as you know, nowadays we rely on technology, and not only technology, but iPads and tablets and touchscreen activities.
Right.
So in this particular investigation, the crew members will do several tests throughout their mission to identify, and all of their tests are going to be done on a touchscreen tablet, to identify how their reaction and the fine motor skills evolved as they stay on orbit, and particularly during a one-year mission. So they were tested before flight, then during flight to measure and identify the adaptation process, and then after they come back to the ground to identify how they readapt to the Earth's gravity.
And it's important because crew members need to still have those fine motor skills to do their jobs.
Yes, especially on orbit, as well on the ground, but on orbit they have to work with very sensitive hardware, do repairs on very sensitive hardware, so it is very important that they maintain the fine motor skills throughout their mission.
Be interesting to watch that into Expedition 44 and beyond.
Yes.
And we'll have an opportunity to check in with you again then to find out how it's going.
Sounds good.
Expedition 43 and 44 lead increment scientist Jorge Sotomayor.